But we finally found it, and now I'm in there all the time, so I know where it is. But
Okay, we are going to take what we've learned and we are going to apply it to probability. Now, I'm a little nervous about this because this is a little bit harder to comprehend. Okay, so if you open your book to page 546, example number 3, it might help if you look at it while we're doing it. 546. Okay, y'all remember probability is success over total. Okay, like if somebody came in here and said, oh, I'm gonna take one of you, I don't know if y'all ate lunch already, one of you is gonna go to Pizza Inn with me. Well,
I know I have
obviously
lunch.
you would like wanna go, so the probability that you would be chosen would be 1 out of 4. There's 4 total people in here and you would only consider yourself to be successful. So it would be a 1/4 probability. So if you remember right, that's what probability is. So point A and B, here's point A and B, are on the circle so that the measurement of arc AB is 60. Suppose D is randomly located on the same circle so that it does not coincide with A or B. In other words, I'm not going to put it on A and I'm not going to put it on B. Okay, now I've drawn it up here. But I don't know that it's right there. It could be anywhere around here, okay? What is the probability that the measurement of angle DADB equals 30? Now, if I shifted this thing anywhere, I could even put it right here. And if I put it right here, it's going to equal 30, right? Is that not right?
Put where?
Okay, if I put D right there.
Mhm.
Okay, so anywhere around here, D is going to equal 30. The only spots that it's not going to equal 30 on is if I put it somewhere between A and B. Because if I put it between A and B, then it could equal 120. Okay, because if I put it right there, then we're talking not 120, but it would be 150. Okay, because this right here is 300 and it would be half of the 300. So I'm looking to find out what is the probability of me putting it anywhere around here. Well, so success, there's 300 degrees that I would consider successful. Anywhere all the way around this circle would be successful. Out of my 360 degrees, correct? Okay, so that is going to give me, and the truth of the matter is, if I reduce that down, they do it a much more complicated way, but this is the way I would do it. If I reduce this down, basically I've got 30 over 36, so if I divide both by 6, I have a probability of 5/6. Okay? Now, if I wanted to know what is the probability, and that might have messed you up a little bit by me drawing it in there, but the book drew it in there. So if you will, you've got lines there and lines there. If I want to know what the probability that placing the B on there is going to give me 150, then I would have success of 60 over 360, or 1/6.
Wait, say that again.
Okay, if I wanted to do just the opposite, and I said I want to place my D on this circle in such a way that it's equal to 150 degrees. Well, that would mean that I would want it somewhere between A and B, so that when it intercepted the arc that it's going to intercept is 300 degrees. So that would give this 150 degrees. So somewhere in that 60 would be what I would consider successful. Okay? Let's do another one. Actually, I'm going to read it. I'm going to see what y'all can do with it. Okay, so y'all can wake up. All right. Points M and N are on a circle. Okay, so let's draw the circle. Just like the side of this one we just did. They're on a circle so that's 72 degrees. Suppose L is randomly located on the same circle so that it does not coincide with M or N. So in other words, I'm not going to place it on top of those two. Okay, what is the probability that the measurement of angle MLN equals 144? Now, I'm going to tell you, success is either going to be between those two or it's going to be out here. It's going to be one of the two. So find the probability. Okay? I want that angle. When I put the L on there, okay, when I put the L somewhere on this circle, I want the angle MLN to be 144.
Okay.
Okay, so what's the probability of that?
What do you mean equal 144?
Because when I take half of the arc, I'm going to get 144. So where do I have to place it? If I placed it, let's say I randomly place it right here, L. What's L going to equal? Half of 72, which is 36. That's not what I want it to equal. Okay? So if I'm thinking about it, anywhere around this circle, if I placed it over here, it would equal 36. I don't want it to equal 36. So where am I going to have to place this L so it
How do
actually
you know that it
equals?
equals 36 if it's connected to
Because
something?
it's half of 72.
Oh, so you would want it.
And I don't want that.
So
I want it to equal 144, so where do I have to put it?
between M and N,
That's exactly right.
And
I
so-
got to put it somewhere here.
then it would be 5/4.
Okay? So my success is anywhere in those degrees. So I have 72 over 360. What does that reduce down to? 1/5. That's my probability.
Okay.
Okay? Does that make sense? It's really not hard, it's just weird. Okay. What if I have an angle that inscribes a semicircle? Okay, let's say I've got that angle. What's the measurement of that angle? This angle right here. What's the measurement of it?
180. Half of 180.
Which is?
Say 90.
90. If I have an angle that inscribes a semicircle, I've got a right angle. Okay, every single time. Same thing, it inscribes 180 degrees, so I just take half of it. That shouldn't be too difficult there, I wouldn't think. All right.
Big smart.
I want you to do this one, okay?
I'm really tired.
I can tell.
You guys tired?
I think you guys struggle in here because you always have math in the afternoon.
I know.
And
I've already
math-
done so much before
Yeah.
this class, and I'm trying so hard.
Math in the morning is so much easier.
Like even on, Wednesdays are usually okay. It's the Tuesdays and Thursdays. I'm just like, I've had 2 classes already, and then there's homework before that. Just really trying to like get all your time.
All right.
Managed.
Find those angles.
Oh, we go.
Okay, now, hold on. We got more information here.
Information. Oh my goodness. I did something wrong.
Oh.
I wrote it again.
Alright, because that's gotta be 90, because it inscribes a semicircle. That has to be 90, because it inscribes a semicircle. These two together, or these three together, have to equal 180. So really the easiest way is just to go 12x minus 8
I left
plus
off.
3x plus 8 equals 90, because that would have to equal 90.
I left off the 90.
Okay, can't really do it without that, okay?
Yeah.
15x, then the 8's go away. So I've got 15x divided by 90, which is I think gonna give me 6. Okay, so then I could plug back in and go 6 times my 12 is gonna give me 72 minus 8 is 64, so that's gonna be a 64 right there. And then if I plug it in there, that's gonna be 18 and 8, that's gonna give me a 26. Okay, you with me so far? Then, let's see, what else do I know? Do I know 3 and 4?
3 would probably be 26.
Well, I will tell you that those angles are going to have to be congruent. Because if that is, no, not necessarily. I will tell you that supplementary angles, those would have to be equal to 180 when I added those together, and those would have to be equal to 180. Because there is, and I think that it's in here, but I don't know that they've told you that. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So this and this would be 180, this and this would be 180, but I don't know that that really helps you. So let me go back, let me see. Does it, oh, wait a minute. It tells me I left out this part. Those two are congruent. If those two are congruent, then those two angles have to be congruent, because they inscribe congruent. That inscribes that, that inscribes that. Those are congruent. So these would have to both be 45. Okay, it would have helped if y'all had all the information. Okay? All right, I'm going to give you one more try, and then I'm going to give you your homework.
Trigger.
All right.
That was a horrible circle, Rachel.
All right, this is what I know. Angle B is 80 degrees. Angle C is 40 degrees. And I need to find angle A and angle B. That's all the information I got. And this time I double checked, to make sure that I didn't do something else. should I got it?
Sure.
I mean, I did it, but,
Gotta be
Okay.
something different.
angle A should be 140, and angle D should be 100.
No.
Good. Okay, let's talk what we know here. Okay, this right here inscribes this whole thing, so from here to here should be 80. Okay, this inscribes this whole thing, so then we're talking from here to here.
How do you know what it describes that whole thing?
Which would be 160, because that's the angle,
Oh,
right?
Yeah.
Okay,
Yeah.
now A,
Then you have 180 left on the other side.
not necessarily, because it's
Oh.
not through the center.
Oh, that's true.
Wouldn't A be 140 because opposite angles are?
Pardon me?
Wouldn't A be 140 because opposite angles are supplementary?
Yes. Okay, based on that theorem, so, like this, because that and that have to be.
Wait,
equal to
why is
180.
it 140?
Okay, because of that theorem that we just had, and you're right, that was the easier way to do it. This is a quadrilateral, it's inscribed in a circle. According to that theorem, opposite angles are supplementary. So if I know the 40, this has to be 140, because that's the angle opposite. The two together have to equal 180. This plus this has to equal 180.
Oh, cool.
You're right, that was the easiest way to do it. We were trying to make it a little harder than that.
I just said
I was trying to.
That was the way I did it.
I just
So,
said
I didn't.
80 plus 40 minus 180. This is what I'm good, and I couldn't.
Did you get the right answer? No.
Oh, okay.
I did it. I did it really interestingly. I was like, 180 minus 80
You did
minus
the Rachel way.
40, and then I was like, this is what I got. So then I cut it in half, and then I gave each half, and I was like, this seems reasonable. Oh, I'm out of paper. Oh no, I found more.
Okay, and then at the back, a little bit more work on what you did for homework today.
Spin me around in circles, man.